So if you remember how the HSI model works, at some point you're not going to notice that blinking anymore because your brain's going to just assume that that's kind of the normal. This semester is kind of strange because we lost the 3 days. So every day basically before class, I'm trying to figure out how to get you the right material at the right time. Today we're going to be talking about modeling. So I got some questions on the Piazza. First, is there anybody who has not figured out how to do the Piazza or is not plugged into that yet? I didn't check to see. Are you having problems or you have not tried? To the Piazza or to Moodle? Piazza. I'll need you to send me an email. So today's quote is, "We can make decisions, we have free will." I can't really prove that. There's this debate in philosophy about whether or not we just pretty much do the things we do because of the things that we did before. So it says, kind of thinking about if you throw something up in the air, it's going to fall. It's going to fall, or at least we think it's going to fall. Right? So depending on the state of where something is and what's going on, if it's inanimate, then we just assume that its future is determined by its state and the properties about its changes in state. If it's a human, we just assume that for some reason that's not true, at least about some parts about humans. But there is this philosophical question about whether or not it is or isn't true, whether or not we can decide things or we just do things based on our experiences in the past and the state of being that we are. When you look at the HSI model, it suggests that actually most of what we do is not really free will because we don't even think about most of the things that we do. It suggests that there's a variability in the amount of free will that you have to decide what you do. And that depends on how active and engaged you decide your consciousness is going to be on a regular basis with your subconscious. And if you decide you're going to leave your life to your subconscious, then theoretically you don't really have that much free will. Most of what you're doing is based on things that have already been decided by someone or by you. So William James was a famous philosopher a long time ago. There aren't any new reading here because I know your homework's coming up Wednesday at noon. I have office hours tomorrow and also Wednesday. If you come to me on Wednesday for Wednesday's homework, you're probably not going to get a whole lot of really helpful stuff, because usually when I help people, I try to help them, which means not give them the answer, but help them figure out how they can figure out the answer. So, but it's there, so you're welcome to come either time. My office for the office hours is in Rectoria, which is in Jose de Diego, so it's not in Stephanie. You just walk over to the main building where the clock is. I'm on the second floor. And just come on in. Yeah. Question regarding the home?
You access it to
yes.
And it says that it only has one attempt. Do you have a limited time?
Yeah, you can open it and you can go through and start filling stuff in. You're going to have one time to hit like submit.
Does it have a time limit or just like a date?
No, well, it does have the time limit, which is the due date. But no, you can open it.
You didn't open it and then
Yeah. The one attempt is once you hit submit, then it's submitted. So we're going to be talking about things related to homework when we talk specifically about modeling. And there was a question in that a few people asked about, is the model basically the HSI model? And my response in the Piazza was, not exactly, because if you look at the question's talking about things that are happening. They're sort of active verbs. You can use the HSI model to describe things that are happening, but it's not really in the model because the model is at any given point in time. So how do you, if you want to take that model that's at any given point in time, describes you and it describes how communications would flow in you, how do you turn it into a model that that's really talking about the thinking and the feelings that you're having? So this is more of a look at yourself towards that you can use for the professor, basically, for the model. So what I suggest you do is, unless you've been in a professor's head, what I would suggest you do is you look at yourself first and think about how you work, and then think about how maybe you could adapt that to a professor, trying to compensate for any differences that you believe there are between how you operate and how the professor operates. And keep asking the questions on Piazza. It took a little longer for me to answer than it normally would, just I think because it was a strange time in the weekend and I was traveling. Normally I'm pretty fast. Question?
Sí, es también relacionado a vacunación, ese ejercicio. Si
If you want to think about it, and then I'll have more time for questions. I'm actually going to talk about the homework also, yeah, after I go through the modeling. Okay, so this I was hoping to redo, but I didn't. But this is from last year. But this is a site called captionbot.ai, and the idea is a Microsoft site. And the idea is you put pictures, and it attempts to describe to you what the picture is. So the idea was that if you were taking a bunch of pictures, this system then eventually would be able to give you sort of descriptions of your pictures, not just show you the pictures and have you decide what's in the picture. So this is Microsoft, and the question was, what is this a picture of? Anybody have like to share their thoughts? Yes.
It looks like a game of tic-tac-toe.
So it's a game of tic-tac-toe. This happened to be sitting in an office at a bank while I was waiting for someone to come talk to me. And I just took a picture of it. You could also think of it maybe as a piece of art, because it's not your regular tic-tac-toe. So I just uploaded this into Microsoft, and what it said it was, I think it's a clock hanging from the ceiling. And here's another one. I think it's a vase of flowers on a table. There actually is kind of something that looks like a vase. There's no flowers in it. Yeah, there's a painting of flowers. So it's doing something, figuring out something things that are in there, and then trying to put a story around it. It could be, but it could be a dog wearing a costume of an elephant. Would have been more impressive if it said, I think it's a dog wearing a costume of an elephant. More advanced. So this, when you put this together with what we showed you, I'm not sure why I have my shades on. I'll keep them there so I don't forget them. If you put this together with where we ended last time, where we were looking at Sophia and some of the code descriptions that went into creating Sophia and the model of the robot operating system that had the event handler that had the responses, if you recall, about what she would do if you said something that she thought was irritating, and then how she would move. That's what we call scripting. And then what I was showing you here is really more pattern recognition of images, trying to identify things in images, and then to a higher level, which is even harder, not just identify some things that are in images, but use the identification of things that are in images to try to put, a description around it. And so one thing we can see when we look at Sophia, and then when we look at things like the Microsoft AI bot, is that whatever it is that the artificial intelligence algorithms and software are doing, it's not what we're doing when we're thinking about things and we're looking at things. So much so that you could look at something that that looks like a tic-tac-toe board or looks like an elephant, and you know whether or not it's an actual elephant or a picture of an elephant or a painting of an elephant, a work of art. You have a lot of different ways that you conceptually decide that something is something based on what you're looking at, what you're hearing, and where you happen to be yesterday or 5 minutes ago or 1 minute ago. You can have within your consciousness and subconsciousness just been talking about costumes, and if you look at something you might think of a costume, whereas if you hadn't just been talking about costumes you wouldn't necessarily think about costumes. So again, there's a lot of things that we're doing. What we can say is if you envision a career for yourself of making like super intelligent robots and artificial beings, there's still plenty of opportunity, because even the smartest folks working hard with the billions of dollars of resources are still figuring some things out. What can we say about human level AI if we want to get there? To get there, that's where I think that it's useful to think of human beings and create models around those human beings. So you can begin to get your arms around how human beings really do think. I'm not going to show this video here in class to try to gain a little time, but I already put the link on Moodle. So if you go into Moodle, towards the bottom of the page, there's a section that says links, and that's there. It's only like a three and a half minute video. It's kind of a funny video. It's got some really famous scientists and some funny scientists talking about models. So I suggest that you look at that and think about what models are and why they're important to science. This is a little bit more specific. When you read this, and hopefully you read it once, because the first time I read it kind of gave me a little headache. It was a lot of information, a little bit dry, not that much fun. But when you read it the second time, I'd suggest you have this slide in front of you so that you can check yourself. So read it and see if you can answer these questions. And if you try to answer the questions and you can't, then go back and look for it and answer the questions for yourself, because it's important that you're able to understand what these concepts are. I'll explain now once. And so hopefully it'll seem familiar when you look through that again. This isn't stuff that's going to be explicitly on your homework, but it is stuff that if you know, it'll help you to make a better model when you're making the model of the professor. So one thing is that, so these are attributes of models, and let me try to hide this thing here. So these are attributes of models. One attribute is that they relate to a target and are designed for a specific purpose. So I'll give you an example. In your homework assignment number 3, the model that you're going to create is related to a target, and the target is the professor that you're selecting. So basically the object of the model that you're creating. It's designed for a purpose. One of the purposes is so that you can complete your homework. But the other purpose is so that you have something that you can reference that helps you better understand your professor. So if you've done your model well, the model has some attributes of your professor. Maybe your professor is absent-minded, or maybe your professor is very, very detail-oriented, or maybe your professor speaks in multiple languages. You get to decide what's important for your model, because models simplify the real world, and then you can test your model over time and see if you have to make adjustments to your model. So based on that, models allow scientists to make hypotheses and test them. If the model is correct, then it might suggest that in a certain experiment, the professor would behave in a certain way. So that could be something about your model. It bears some analogies to the target. So the model should have some analogies, meaning sort of like similarities. I don't know how you say that in Spanish. Analogy, does anybody know? Huh? Semejanza. Wow, okay. Semejanza. And then it's going to have differences, of course, because there's going to be a lot of simplifications. I'm not asking you to create a model that describes every single aspect of your professor. Models trade off similarities and differences. Different models may coexist for a different target, and models are developed iteratively. So normally you have a model, you test it out, you realize that some aspect of it's not quite correct. Maybe you left out some variables that are important for the model, and you go back and change the model. The nice thing about being people that are interested and capable of writing software is that if you can build your model and then turn that model into software, you can run all sorts of simulations on that model to see what the model actually does. And then based on the outcomes of those simulations, you can change the model. So that's something that's extremely valuable in computer science and software development, which other disciplines don't necessarily have that ability. If you have a model about economic development or the predicted stock market prices, those are two different things. If it's economic development, it may be hard. You may have to wait till the economy develops before you can iterate the model. If it's the stock price in a few minutes, then you can use software and test out your models and figure out if you left something out of the model that might help you better predict what the stock price is going to do. All right, so to take out some of the mystery, this is intended to be a very simplistic model of how a computer works. It should look simplistic to you. There are things about the computer that aren't in this model specifically. This model says that there's an input device. If you look at this very old computer, there's at least one input device, which is the keyboard. In a more modern computer, there might be a mouse, there might be a microphone. If you look on the right side, there's an output device. There's actually a few output devices. There's a disk drive there where you could potentially output some data, which also can be an input device. And the screen, exactly, the screen's an output device. And then what it says is happening inside the computer is that there's a CPU, a central processing unit, and that CPU is comprised of an ALU and a CU. Right? ALU being an arithmetic logic unit, basically the basic math that runs computations, and that there's a secondary memory and a main memory to the computer. It takes input, does things to them, uses some sort of memories and sends out outputs. That's a perfectly reasonable model of a computer. We talked before about the OSI model, which is where we derive the human version of the model. And the OSI model is a networking model of the computer, communications that are going on inside of the computer. So again, a computer, but you can look at a computer and create different models depending on what aspect of that computer you're interested in. So when you think about your professor, you need to think about what aspects of this professor do I want to capture in my model. And hopefully you decide to capture interesting aspects of your professor, because I have to read all these things. Okay, so we can look at a little bit more, well, this is a much more complicated view of a system. This is a control unit, basically a microprocessor, and that reacts to things. But we've created a very simple model of this particular control unit that says there's a clock because it's a digital control unit, so it's bringing in an input clock signal and it's using that to do its math. It's got some flags, right, to let it know what sorts of events it may need to take into consideration. It has instructions, so basically the software that lets it know what it's supposed to do, what it's programmed to do. And then it outputs control signals and inputs control signals. It also outputs some control signals within the CPU itself. These are going to the bus of a computer. So another fairly simplistic model of a very complex system. This is a complex model of a human being, right? So now we looked at two models of computers, and hopefully those are somewhat familiar or you could follow them. Now we're taking a look at one person's view of what a human being might look like. Here, they're describing how a human exists or does things, if you will, the actions they take in an environment. And so they've decided to say, okay, there's some environment here. There's going to be some bus, if you will, that allows us to get to perceptions that are going to be thought about by a reflective process, as well as deliberative processes, and that there is also going to be reactive processes. And then there are going to be actions which consider long-term memory, interactive, reflective processes, and deliberative processes. They're not shown here to interactive, reactive processes. And here, this particular person thought it was important to consider the motives when determining the actions. So they think that the person wants to accomplish something that might fit into this as they're deliberating what they want to do. They have what's called a variable threshold attention filter. And in their mind, that if there's something that doesn't warrant enough importance, then it's just going to be ignored by the deliberative process and or the reflective process. Right now, you probably don't see that flashing stuff. Is it there, or did you just look there? But that's kind of the idea of this model. I do not want you to go home and draw this thing and turn it into. I'm very familiar with this model. I actually don't happen to think let's just say that I think that somebody is going to do much better than this model. Sure. What's important I'm expecting to see 20 plus different models. I'm expecting that you're going to think about the human being that you have the absolute most data about, which is yourself. To at least come up with some of the things that you think should be in the model. Then you're going to need to think about what parts of that model are extensible to the professor, and maybe what parts you may need to add. Right? So if you feel like you're a caring person and the professor's not, then you might need to take out the caring module that's associated with that extension to the professor. If there's some attribute about the professor that you don't really see in yourself for whatever reason, then that might be something that you want to add. But I would suggest that you start thinking about yourself and then transition into. And then read the question. My experience from last time I taught the class is a lot of the points were just missed because the question people didn't really study the question. So don't just read it to start answering, just really look at it. Because there are some themes or ing, like we'll see in a little bit. There are words that suggest that things are happening. Behavior, feeling. So your models needs to somehow capture that. What I'm going to be looking for is that the model, that you've thought out the model well, and that you've described it so that I can understand. If I read your description and I still have no idea what the model is, that's not going to be good. I'm not looking for it for a model is the model. Although I observed that I can see take some of your better models and use them later on in the class. This is a hypothesis that's central to thinking about applying human perspective to artificial beings. And what it says is that human intelligence is built on using models. And that's why we're learning about it. And those models you can think of as concepts of the world. You have a model right now for how the world works. Your belief is that if I take this card, when I flip it, it's going to be the same card when I turn it around. It is. Your belief is that when I let it go, it's going to fly away. All these are concepts. Your belief is that if someone's going to come into the room, they're going to walk through that door. What if someone just walked through the whiteboard right now and stood here? That would be a slight change in your concept of what's possible. But not an insurmountable change. Went and home on the news, you saw that aliens had come and they had this ability and they're up in all sorts of different places. You would adjust your concept. Part of this, I guess, we're not alone. And these people can walk through walls. But generally, you have concepts, and as long as things behave like your concept, they might be like that model we just saw. You have an attention filter, and your filter just doesn't even pay any attention to it. So what this hypothesis is that you're using these models, these concepts, and as long as when you move your leg, it actually moves. You don't even think about it. As long as when you want to say something, you can say it. These concepts change over time. As you learn how to do things, you get better at it. If you're learning how to swing a bat, hit a ball, as you practice more, you get better at it, and your concepts align with a whole bunch of other processes that are going on, and you get real good at it. We've talked about that before. These concepts allowing you to simulate the world around you. We talked about the virtual reality that's in your head that you thought, or some of you might have thought was the real reality, that you would imagine in your world all the time. It allows you to simulate it and predict things, and as long as those millions of predictions every day or more are as expected, then we mostly ignore them. When that person walks through the whiteboard, we're not going to ignore them. What we're going to do is we're going to learn. Our attention filters, probably all of our attention filters are going to go off. And our mind's going to be, what could be going on here? What's happening? Are we in some sort of hologram? Or is it me? Did other people see it? That kind of stuff, right? But we're going to be learning. We're not going to go home and somehow forget that a human being walked through, or some being walked through the whiteboard. So if you think of, from an AI perspective, and artificial beings, not static, but rather dynamically, how do you behave dynamically? I think you'll do a much better job at engineering artificial systems. And the dynamically means that you as a human being aren't waiting around for things to happen. You're not waiting to see something and then decide you're going to interpret it. You're actually predicting what you're going to see. So here, you're predicting you're going to see me in the next instant of time. In the next instant of time. You're actively predicting. And if your prediction doesn't match to what actually happens, then you're going to react to that. And if it does match, you might get paid attention. That's the hypothesis that we have. So if you want to engineer high-performance artificial beings, it's not that you're going to have a bunch of microphones having to listen and decide, or a bunch of cameras having to watch and decide. We're going to actively predict what is going to happen, and what should be coming through all the sensors next. And you're going to compare that to what actually is coming through all those sensors next. I'm going to pause here because this is really could be a new concept. Because sometimes we think about, well, there's an input I evaluated, and then there's an output. This thesis is saying that it's not like that. You are active, your brain is never just sitting there, it's actively predicting, creating a simulated reality and predicting the next simulation. Which, by the way, is kind of how compression works, or decompression. If you're doing a video, the reason you can take a video that normally would have a lot of data associated with it, cut it into time, is because you're making use of the fact that one frame is very similar to another frame, is very similar to another frame. Your brain's doing the same thing. It's making use of the fact that the reality it's in now, with the concepts that you've learned, are going to create a next reality which is pretty cool. And if you're talking to someone who you're really good friends with, or a family member, oftentimes you kind of have an idea of what they're going to say next. And if they don't say that, or if they do say that, it feels right, it feels comfortable. You feel like you understand them. But if they say something totally different, you must pay attention. What questions or comments about this? It's a lot of information. I know you guys can do it. Questions? Does anybody want to explain what this thesis is?
So I read this in my the HPAI model, and it says that the five concepts of things that, well, we want create instances as things happen quickly and with one's time. You know, so part of learning and predicting is like when you learn to relate out these concepts, and so that's what I remind them. We have little models in our heads, like what we expect of things and events, and sometimes surprise and new instances are created.
Very good. So, just to add a little bit to that, the predictions may be conscious predictions, but most of the predictions can be done subconsciously. So the predictions that your mini modules are actually making, that to the extent they're right, that you're not going to get much, or to the extent that they're not different or unusual from what you would expect, then you may not ever actually know that. So if you're running down the stairs, you're running down the stairs mini modules. And those subconscious layers are predicting what's going to happen when you do this with your foot. And there's going to be something to support you. You can move this down. As soon as there's a rock or something, or one of the steps is uneven, the predictions are off, and you're going to notice that if you're running down the stairs. So if you find yourself struggling with the model, main thing is to look at yourself and think about what's important when you're behaving, thinking, and whatnot. And I'm expecting you're going to have boxes and circles and arrows and lines, but last year I got all sorts of stuff, and it was all good. So. And this is the question. Imagine how the professor, and these are active verbs. I don't know how to say this in Spanish. ¿Cómo piensan siempre y actúan? So meaning they're doing things, whatever it is that they're doing. You can see the model. You're going to draw up your model. You can draw it by hand. You can get your computer out. You can take art from different places and collage it together. Most important, I think, once you think about what's important, and just draw it out and connect where you're supposed to connect, that kind of stuff. And then most importantly, describe it, because I'm expecting everybody's going to have a different model. What makes sense to you when you look at it, it's probably not going to be what I would think of when I would so I need some additional information to explain how this works. Hopefully this is a fun exercise. All I can tell you is it's a useful exercise. Yes?
We have to collect, think, feel, and behave models together, or they should be.
It's all of those things should be in the model.
So they should be connected, or should they be separate?
Only if they're connected. If you think, feel, and behave independently.
If they depend on some other concepts or we can include some other figures or circles for example, knowledge or emotions.
Absolutely, yeah. You saw some examples here where there was a lot of detail in certain areas, and you saw some examples where there's a little less detail. You can combine that in your models. There might be some things for the particular thing that you're thinking about for the professor in terms of how you feel where you want a little more detail. Okay. Here we're going to talk about decision making. Do a time check. Good on time. This is the classical decision-making model. I've yet to make a human being in my life that makes decisions like that. If you go to like old business school books and things like that, they tell you like this is the way that you should make decisions. And I've been in lots of seminars and trainings throughout my life where I've looked at this model and things like this. And I've always felt somewhat insufficient because I didn't have the patience or the focus to do all these steps. 7 steps. First step is decide, identify what your decision is. But it's not what the decision is. Not what you decided, but what you decide about. And so for this example, we're going to help the professor, in this case me, and the decision that we want to get to is what new, for me, restaurant in the Maya West area should I eat? Where should I like to go out to restaurants, especially when I've had a long day, I don't feel like going home and cooking. Maybe my wife doesn't want to cook either. So we go out to eat. We are very loyal people. We like to try new places, but if we find 1 or 2 places that we really like, we're going to keep going to those places and then tend not to try new places. So what I'd like your help here is to help me identify a place that I have not eaten at that I could try. And then just to clarify here, it's not that it has to be a new restaurant. It could be here 30 years, just a restaurant that I haven't tried. So that's the decision. Now we need to gather some information. Your decision, you're going to make a recommendation. So right now, you probably don't have a lot of information you need.
We try Castellanos.
And I tried Castellanos. I don't know. Where is that?
Going to Western Plaza.
Before the holiday.
Before the Holiday Inn.
Yeah.
Is it the place that's across the street? Right on the same side as the Holiday Inn?
Yeah.
It's kind of got an outdoor area.
Yeah.
And, okay, that's a really good question.
Like some stairs.
Huh?
Like some stairs.
They go upstairs to the whole patio. I have tried that place. I tried that place twice. And it was not my favorite. There are attributes about the place that I really like, actually. But my problem is that I lived in Texas for 10 years. We have a lot of Tex-Mex, Texas. And I tried like their nachos. All right, good question. All right, so there's some, you've learned a lot right there in the information about, not just about Castellanos, but some feedback about the place. Other questions?
If you like sushi, there's a sushi restaurant in the side. I think it's really good, but people don't go.
Inside. Okay, so I'll give you some feedback about inside. I've not been to inside. But there was a rumor that they don't have soy paper. So I don't know if it's true or not. I've never actually been there because the rumor kept me from going there. So soy paper, normally you wrap sushi in seaweed. And for me, I taste the seaweed. And so if there's things like tuna, to me they have sort of subtle flavors. When I eat sushi, I like to be able to taste if they put, the tuna with some mango and a little bit of a little sliver of avocado. I like to be able to taste those flavors. in my mouth, and when I put the seaweed, I just put seaweed. So, huh? I think I had breakfast there this morning. Really good. And I get some feedback. Really good. I think it's more so, it's not really good, it's just I really enjoy it. Because if it feels all uncomfortable, you go, they have all the food to go out there,
And they serve you a lot.
serving a lot of food. Prices are a lot of size. Any other questions? I haven't been there.
I work there.
I'm gonna go again. So I think it was because I heard someone bought it and they changed it, and then I went like very soon after that. And it wasn't bad, but I could give you some feedback. I recently went to this new Mexican place. It was so good.
Direct competition.
It's
So they're not good for me.
Have you been there?
It's good.
I'm not supposed to talk about drinks, but their beverages are really bad. Yeah, there's room for the food.
What's the other topic? Don't know if it's something. I think another video. It's a little bit hidden, but it's really good.
I already like that one.
Okay, so
You
we
might
get
know
some.
that you that you
So on the next one, when we get to the voting part, we should probably put something other than that. So, okay. So we're gathering information to make our decision. We can think about how would a computer, if I asked the computer where should I go, what it would have done. And amazingly, actually, there's some companies that do pretty good at predicting where I would want to go. Because I let them know intentionally, not intentionally, where I go, where I go back to. We get information about other people that go to these places, where they go back to. If you get access to enough people, you can start making recommendations based on what other people do. You didn't ask me what my favorite place to go to. Would that be a good thing to know?
Yes.
At some point, it's going to be secret in my evidence. When you tell me to go back.
We have these new lunch specials. They're pretty good.
So, my favorite place to go is CIIC. It's because, now I'm going to talk about food. It's because I like the environment. It's kind of environment where I don't feel cold. But, people my age, people older, people your age, show up and although to date, I've never seen it on my students. Like you guys have way too much fun. I like the way that they treat my wife and I when we go. Pay attention if we need something a little different. I like that they go. And I like the quality of the food. Their nachos are not Mexican nachos at all. But if you've ever eaten them, they're pretty amazing. They've been eating nachos at Martinez. Something they put in the cheese. All right, so that's gathering information, and what I want you to get out of that part of it is that we talked about food. We didn't talk about location, but we did a little bit about where things were located. We talked about my preferences. We talked about some of your preferences. We talked about some of the things you have connections with. We talked about other aspects about the dining experience, right? All that related to gathering information so that you can help me. We already talked about some alternatives. I'm going to jump ahead a little bit there. And it's anonymous. But if I see Cinco de Mayo on there, it's like, so take a little time. Feel free to recommend something that wasn't even mentioned. I don't know how I lived before Google Forms. I use them for everything. Absolutely everything. So I've actually never eaten at Friend's Cafe. I've had some coffee there at the one here in the plaza. But I think there's another one somewhere.
Yeah, there's one on that area, and it's like sandwiches. I've never been to that. I was the one who had some.
Okay.
But like, I like the environment of the process. The one in the I also have to. But like, I hate it.
Okay. Okay, so Casa Penchi, I heard, was like a funeral home or something like that. The food's to die for. Burger Factory, never heard of it. That sounds good. You know what I've seen? I've walked by there, and I've never walked in there actually. It's near our house, I think, right? Cerveceria. Oh, okay.
That's the also.
Okay. Clara's Cafe, Rock and Go, Sancho Panza. I went for the first time actually last month. I don't know if the food was good for me, but I really liked it. All right, awesome. Well, thanks. And then it says, have you been to it? And so for the most part, people seem to have recommended places that they have been to, except here at the bottom. La Jarochita. I haven't been living in Puerto Rico long enough to go to Chili's yet. So, but someday I know. That's how you know you've been Puerto Rico too long. If you have been to the restaurant, did you like it? All right, so I think this means you still might like it, except for you should go here, but I didn't like it. All right, awesome. Well, thanks for going through that exercise. Let's continue. So we're going through this because we make so many decisions and we don't go through this kind of process. But again, as you're trying to define something that you want to implement, it is important to go through some process, have some reference, because even though we may seem to jump around and intuitively make decisions, and not worry about the details. If you want to program something to do it, at some point you're going to have to worry about the details so that you can decide how you're going to have that computer do that thing, even if you don't tell it exactly how to do it, right? How you program it to be intuitive. Did that already. Definitely gonna make a decision. I will report back. I don't know if it'll be this week, but we'll see. Okay, so here are some limitations on classical decision making. Requires a clearly defined problem. That problem was fairly clearly defined. We could have been here a long time getting all sorts of even more information about my likes and dislikes. At some point, it might have been a point of diminishing returns, meaning that even if you knew more about my likes and dislikes, it probably was. It wouldn't give it a point where it wasn't going to change what your recommendation was, because there's only a certain set of restaurants here. That tends to work best when there's not a lot of uncertainty, so you can actually identify what the options are, identify what's important in making the decision. There's a lot of scenarios in life where you need to do something with someone or approach someone, and you're going to have very little information about that person, and even if you talk to them for a while, you're still going to have a very small amount of information compared to who that person is. So as soon as the information is available, and it's based on making somewhat rational decisions. It's a busy slide. At this point, I just want you to think about and accept that despite this classical decision model being something that's been around a long time in business courses and other types of seminars and trainings, very few people actually do that. And I wish someone had told me that, because when I was looking at this stuff, I was thinking, well, I could never be a leader or lead an organization, because I just start going up, I get bored, I think about something else, skip a few steps, go eat somewhere, it was bad, come back. So my process is actually a little bit all over the place. If it's a Mexican restaurant in Maya West, I'm going to try it. Even if someone says it's bad. So there are going to be some rules of thumb. People call them mental shortcuts, educated guesses, intuitive judgments, common sense. All that still sounds fairly educated. I actually make a lot of decisions without really giving it a lot of thought, thinking all the consequences through. Sometimes it just might be because the risk of a bad decision isn't that big a deal, so it doesn't really matter. If someone wants to take me or meet me somewhere I haven't been, I'll just go. There's not really much downside. I'll learn something about the person that invited me there. People rely on a reduced number of these principles for most of the decisions that they make. If you think about the HSI model, you can understand why that is. Remember, the consciousness is fairly slow. It can only really keep track of a little bit of information at any given time. You may actually decide to go somewhere, get there, and then remember why you didn't go there. I've done that. I've gone to a place, been there, and I was like, I forgot, this is why I don't go here. But they do allow for simpler judgments. They allow you for not to be like thinking about where you're going to eat for a long period of time. There are times that I cannot decide where I'm going to eat or what I'm going to eat. And it's a challenging time for me. It happens fairly reasonably often, and it's because I'm really, really hungry. I'm so hungry that I become impatient. My mind just starts not being able to make a decision. I have to now think about the model, remember that I'm in a place where my subconsciousness is not allowing my consciousness to make a decision. My consciousness has to somehow force my subconscious to allow me to eat something, even if it's just a cookie or something. And I do that, and all of a sudden I can think again, and then I can decide where I want to go. Then I feel a little bad because I'm trying not to eat cookies. But sometimes you gotta eat the cookie. If that's the only thing that's around, and you know you need to eat something, just remember the HSI model says that you have to solve that problem. Otherwise, your consciousness is captive to your subconscious processes that are very powerful. This can happen when you find yourself behaving in a way that you don't want to behave. You feel irritable, and you're maybe taking it out on your friends. Go eat, take a break, go somewhere else, and allow yourself to bring that balance in. You'll see throughout the class examples of why that happens. We're actually ahead of schedule. I don't know how that happened. Don't worry, we'll have some interactive time. So some things to ponder that we've talked about. What is the nature of human intelligence? Can software and hardware combine to achieve wisdom? Can artificial general intelligence, basically making an artificial being as capable to make decisions and as free as we are, can that be achieved? Can it be engineered? And if we acknowledge that we're not there yet when we look at Sophia and think about the Microsoft clock, what are we missing? What do we need to do differently? We need to think about massively parallel systems that are largely computing things in real time, independent of the overarching logic of that system.
And the second question, how would you define wisdom?
Good question. I don't have it here, but it is here. So this is how I define artificial general intelligence. We're going to define it like this in this class. And the reason is if you go out, there's no real consensus on what artificial general intelligence is. Some people say that it's got to be smarter than a human. Other people say it's got to be as smart. But even that kind of breaks down, right? Because as we saw last time, I can ask Google what the time is in Tokyo, or cities that some of us have never heard of, and it's probably going to tell me the answer. So there are certainly things that computers seem to be able to do, or problems that they're able to solve better than we. At the same time, there's other things that we do that they don't seem to be able to do as well as we do. So we're going to define wisdom here as part of defining the AGI as the quality of having experience, knowledge, and sound judgment, which admittedly is not very satisfying from a quantitative standpoint. But there's a suggestion that as smart as you are sitting here today, that you will be more wise 10 years from now. I'm not saying older people are more wise. I'm saying that each of you is going to be more wise. If you want to infer from that, people that are 30 to 35 generally can be more wise than people that are 20. That's your so I believe that each one of you, as you get older, are going to become more wise. Is there another question? Yeah.
Well, we are talking about artificial intelligence. How do we find it?
I think for me, I define it as something that's not biologically sustainable and reproducible on its own. So like a plant is living. Have you ever seen the plants that like you touch the plant and it closes? But not the whole plant, not like the flight that you touch the leaf and it closes. Have you ever done this to someone? What do you do? What if you were a plant? People came by and touched you all the time and they did it. But they stepped on you. So I think that actually we underestimate the intelligence of things, of beings that are imitating their life. I've seen things do some pretty amazing. We've done some experiments where they take that kind of plant and they drop it on the floor, and the plant like closes. And then they drop it on the floor, and the plant like closes. And they drop it on the floor, and the plant doesn't close anymore. And then like a month later, they drop it on the floor, and the plant doesn't close anymore. I'm not going to explain how it works because unfortunately I can't have a conversation with the plant. But there are some things when you really start to look at even plants, maybe if you have pets, it's probably a little bit more obvious that they interact in ways that suggest that they have some intelligence. Even though you'll read a lot of books and papers that say that human beings are the only ones that do this, that, and this, and feel this, that, and that. But I can't prove it to you because I'm not inside of a puppy. For that matter, I've never been inside of another human being.
I have a question about the meaning models. How big or small can they be? How, let's say, it could be like design your shoes. That could be a meaning model. Or can it be reality? Can you say that just letting reality be what it is, just not thinking about it, not questioning it, could that be a meaning?
Yeah, I mean, remember the menu modules are a collection of instances that are in parallel. When you tie your shoe, you could argue there's a lot of instances that are collaborating together to allow you to tie your shoe. Do you tie your shoe differently when you look at it versus when you don't look at it? Do you tie your shoe without looking at it? Do you? Why do you look at it when you tie it? There's some collaboration going on there. You should try it. Yeah, and see how fun you feel. That is so that's a really good question because it helps to understand that there's a lot of instances. Some that are processing visual information, some that are processing tactile information. If your shoelace starts to deteriorate, you'll actually notice that, even if because you'll pull on it, and so even if you're not looking at it, something will feel on it. Or if one of the shoelaces pulls up and there's a little bit longer inside. How many people here? I don't have a QR code for this. And if you don't like to participate in public, that's fine. How many people can like have it like not be going to be okay. You just tell them and move on. Just, you know. And then how many people, like, if it's off, like, you gotta turn it. Yeah. Now, so in the case of the people that are okay with being off, how off can it be? Things we don't even think about, but yeah, and thank you for that, actually. I had not ever thought of that example. That's an example. So complex and sophisticated. There's a lot going on. Thank you for sharing that, because you know that helps you teaching me something and really hearing that. Very helpful for me. Any other questions? Comments? Yeah.
Getting back to the architecture, some judgment gives some one. So some judgment is we know it's right. Who will judge the architecture evidence is right or not?
Not me. I won't judge. Yeah, so there's a qualitative definition, and that's really up to you to decide. Right? That's the nice thing. A lot of things outside of things that are illegal, you get arrested. Most things, you have some ability to make a choice within certain bounds. I think that it's wise for me to do the things that I do with my time. You already know I don't charge anything for what I do. My first interactions here, there was a professor in psychology who was flattering me. Every once in a while, he looked at me and said, why do you do this? He was from psychology, so I thought, maybe I should be a judge. But that was a decision that I made. Right? It's perfectly also wise if I say, you know what, I have to work, but I'm just going to play golf or travel the world or party every night. I like to go on very fun, absolutely. I can't tell you that one's better than the other. Recently, you may have heard about Kobe Bryant's death. I think about people like Kobe Bryant and Steve Jobs that just had an incredible amount of money. They don't have to work. And that they lived their life in a way that they were doing the things that we want to do, realizing that no one knows how long it is to be alive. So those are all personal preferences. I think there could be some things that you would say are not wise. It's something that's going to cause you real physical harm. But this class isn't going to answer that question. And in fact, as you go through, I painfully try never to use words like negative, positive, should. Sometimes I say should, I really just suggest. I would never tell you you should look at things on purpose. You should do what you want to do. And I may suggest because I want you to do well on an exam. For example, Mike. I'm in my office tomorrow. If you're going to come, you can just show up. You can also send a little bit on the piazza or say, hey, I'm coming. I'm sorry, I know you're coming. They are from 808 to 909. I can't be somewhere at 8. Just